All right, here we go. We have a sign, a big, heavy sign. And it's being held up by two ropes that are at an angle, and gravity's fighting it. And the important part of this problem is that these ropes and gravity are all canceling, leaving the sign in equilibrium, meaning it's not accelerating, meaning all the forces cancel out, meaning the acceleration is zero. So let's draw our forces in the center mass of this sign. So here we go. We have one force pulling upward. We have another force pulling upward. We can call these F1 and F2. And then, of course, we have gravity pulling down. We'll call that Fg. All right, so here are the forces. These are the ropes. These are the forces. Okay, the lengths of the rope don't really matter. All that matters is the angle and how strong the forces are. So look at that picture. Okay, you have one object with three forces on it, and they all cancel out. What we're looking for in this problem is what are F1 and F2. In other words, what must F1 and F2 be since the object's in equilibrium? If the mass of the sign is 500 kilograms, which is going to make the forces bigger, and then the angle theta, which is 35 degrees. Now, the angle that they gave us is this. Theta, here, and here. Those are the angles. All right, but I'll keep them there. So there are the angles. Here's the solution. We need to include gravity, and we'll make it positive and factor in the negative later. Okay, so here we go. We're looking for F1, we're looking for F2. Here's the solution. What we want to do is the sum of forces in the y direction, because the y direction includes the force of gravity and it includes the ropes. So we can do this first of all in our head. Look at this, right? Vertically, we know that the force of gravity is going to be equal to its mass times its acceleration of gravity. Well, its mass is 500 kilograms. So what's 500 times 9.81? Well, it happens to be 4,905 newtons. So if there's 4,509 newtons pulling down, how many newtons need to be pulling up? Well, 4,905 newtons need to be pulling up. But there's two ropes, so they each are going to pull up with half of that amount. Right? They're each going to pull up with half that amount. So that number divided by 2 is 2,452 newtons each. 2,452 newtons. Okay? So, very simple. If there's 4,905 newtons downward, then each rope vertically will be pulling up with 2,452 newtons. But that's only the vertical component. That's only the vertical component of the force. These forces, these ropes, are pulling at an angle. So what we need to do is look at the components of each force. What we're going to do is I'm going to draw the x component in blue and the y component in red. Now we're only going to talk about F2 because F1's the same thing but just mirrored on the other side. So the red line represents the y component, the blue line represents the x component. Now we know that the opposite side right here also represents the y component. It's the same length. So we know, based off of what we just reasoned, that this side has to be 2,452 newtons. Okay? And if we know that is true, and we know this triangle has an angle of 35 degrees and an opposite of 2,452 newtons, then boom, solve for x. Oh man, that's super easy. It's going to be simply the opposite and the hypotenuse. We're simply going to say the sine of 35 degrees is going to equal 2,452 newtons divided by x, divided by the one unknown. solve for x. X is simply going to equal 2,452 newtons divided by the sine of 35 degrees. Our answer, 2,452 divided by the sine of 35 degrees. All right, and we get a final answer of x equals 4,274 newtons. Boom, there we go. We're done, right? We know now what F1 and F2 are, simply in our head very quickly.